Welcome. Today I'll show you how we use crew-level hyperscanning with two NIRSIT Lite devices. This is applied neuroscience in operational contexts, allowing us to objectively see how two or more operators coordinate mentally. Most hyperscanning studies equate coordination with interbrain synchrony. They typically rely on methods such as wavelet coherence or cross-wavelet transform to detect shared oscillations across brains, Granger causality or transfer entropy to estimate directed influence, phase locking value, PLV, or intersubject correlation to quantify temporal alignment. The common assumption is, the more synchronous the brains, the better the team coordination. We take a different view. In high-stakes operations, simultaneous high activity often signals joint overload, not effective teamwork. What matters is how workload is distributed, shifted, and balanced between operators over time. Our approach therefore focuses on event-based spike detection with the proprietary Spearfish engine. This allows us to extract meaningful activation episodes for each operator, classify them into 5 coordination patterns, asymmetric, handoff, joint, or no activation, and compute a team coordination index, TCI. In short, while traditional research emphasizes statistical synchrony, we emphasize functional coordination and workload sharing, a perspective that aligns more directly with operational demands. CLH NIRSIT Lite pipeline. We run 2 parallel Spearfish pipelines, one for each NIRSIT device. Each pipeline detects meaningful brain activation events for that operator, either in real time or post hoc. We then align the 2 timelines so we can see not just when each operator is active, but how their activations relate to one another. This alignment is what turns 2 separate brain recordings into a true crew-level hyperscanning analysis, letting us quantify coordination patterns between operators. Combined plot. First, we can inspect the signals visually. This plot overlays the mean activity and the ROI activations of both operators. Colored dots indicate where significant activation events were detected. We can zoom in on any time window to look at details, and when we hover the mouse over a line or a dot, the tooltips tell us which operator it is, which ROI, and the precise time of activation. Vertical dashed lines mark event markers from the scenario, so we can immediately see which brain activations align with task events. In short, the combined plot is the entry point. It lets us explore both participants' brain dynamics side by side with interactive detail before moving to higher-level coordination metrics. Activation timeline. Next, we summarize activations in interactive timelines. Each ROI in each subject has its own row. For example, executive control set A versus executive control set B. Colored bars mark the exact start and end of each detected activation, so we see not just that someone was active, but for how long. We can filter which ROIs are displayed, zoom in on any time interval, and hover to get detailed information about onset time and duration. Event markers from the scenario are also drawn as vertical lines, so we can directly relate cognitive engagement to what was happening in the task. This makes it very easy to spot coordination patterns visually: who was engaged, who took over, whether there was overlap, or whether both operators were idle. It's a bridge between raw signal inspection and the higher-level team coordination index. Definitions: Team Coordination Analysis, TCA. Before we can measure coordination, we need to clearly define what kinds of coordination patterns are even possible between 2 operators. Based on the brain activations we detect, there are 5 fundamental patterns. 1. Joint activation. Both operators are active at the same time. This often signals overload because both are carrying high cognitive load simultaneously. 2. Handoff activation. One operator stops and the other starts within 3 seconds. This is the hallmark of efficient teamwork, showing smooth transfer of responsibility. 3. Asymmetric A. Only operator A is active, meaning A is carrying the workload. 4. Asymmetric B. Only operator B is active, meaning B is carrying the workload. 5. No activation. Neither operator is active, reflecting idle periods or very low cognitive demand. Every moment in time can be classified into one of these 5 patterns, which gives us a complete map of how coordination unfolds dynamically. Team Coordination Index, TCI. Once we have this classification, we can translate it into a single number, the Team Coordination Index. The TCI is designed with operational logic in mind. It rewards handoffs because they represent efficient distribution of workload. It values asymmetric periods since they show one operator carrying the load while the other is free to monitor or prepare. And it penalizes joint activations because overload is a risk factor in complex tasks. The final result is a score between 0 and 100. The higher the score, the better the crew managed to share and balance their mental workload over time. Crew TCI. Beyond looking at coordination in individual brain regions, we can also step back and calculate a crew TCI. Here we take the union of all ROIs and treat them as a single system. This gives us a holistic picture of whether the two operators as a team are engaged together, alternating smoothly, or leaving gaps. For example, if operator A shows an activation, and just as it ends, operator B starts one, that's a handoff, and it raises the crew TCI. If only A is active for a while, that's asymmetric, still efficient because the other operator can monitor. But if both spike at the same time across any ROI, that's a joint activation, and it lowers the crew TCI because it signals potential overload. So the crew TCI distills the entire crew's brain activity into a single score, showing at a glance how effectively they manage their workload as a team. Joint ROI activation. Once we've looked at the overall crew TCI, we can zoom in to see where any overlaps actually occurred. The joint ROI activation table shows intervals where both operators were simultaneously active in the same brain region. These overlaps can be matched to event markers from the scenario. That way we can ask, did both operators engage their executive control region during a critical system alarm? Or did they both switch into strategic planning during a decision point? This view helps us interpret not just that joint activity happened, but whether it was appropriate for the situation. In some contexts, joint activation may reflect necessary joint focus. In others, it may signal redundant effort or overload. This table links brain coordination back to the actual task timeline. TCI overview. Finally, we bring everything together in a TCI overview. Each bar represents the team coordination index for a single ROI, and we also include the overall crew TCI. This makes it easy to see at a glance where coordination was strong and where it was weaker. For example, a crew might show excellent handoffs in visual attention, but frequent joint overload in strategic planning. Because the TCI is normalized to a 0 to 100 scale, we can directly compare across different runs, crews, or training sessions. Over time, this provides a clear, quantitative way to track improvement in coordination skills and to identify specific areas where training or automation support might be needed. Example. To bring it all together, we have an interactive interface that shows all the information we discussed before and more. It is fully customizable and can be extended to a larger crew size. Thank you for your kind attention. In short, our pipeline transforms raw fNIRS signals into a clear picture of team coordination. We can objectively see when operators are overloaded, when they are sharing the workload efficiently, and where gaps or risks appear. This gives us a powerful tool to guide training, evaluate procedures, and support decisions about automation. It's not just data, it's actionable insight into how teams really function under pressure.